got the other, we can go back to 1. So, solve the system of equations. What two methods have they taught you for solving a system of equations?
Substitution and elimination.
Okay, very good. And which method are you going to use here?
Substitution.
Yeah, and the reason is that one of the equations is fully defined in terms of x. Okay, and usually that's what you're looking for to use substitution. In other words, if this was x minus 5y equals 0, then I wouldn't use substitution, I would use elimination. But, so how are we going to do the elimination? I mean the substitution.
Put 5y in for x.
In which equation?
In the bottom one.
Okay, so that's 2 times 5y plus 5y equals 15. Well, that's 15y equals 15. Y equals 1. How do you solve?
You put 1 in for y on the top equation.
Okay, so what's x equal to?
5.
Uh-huh. Now, is that the right answer?
No.
No, it should be 5 comma 1. So it's that right there, C. Okay?
Okay.
All right. Hold on a second. Let's go back and see what else I got from your mom here. Yeah, this looks clear already. Uh-huh. Yeah.
That one better.
Big difference. What'd she say?
She said something to my dogs.
Oh, okay. I thought she was saying something to me. All right. Let's see. The function, which is a quadratic, notice, represents the height in feet of a rotten apple t seconds after it is kicked off the ground. Tell me where the apple is at 0 seconds.
At 0?
Yeah. Okay, here I need to shrink this a little bit, I think, in order to, no, I'm not going to be able to, no, okay, that's fine. Graph the function and label the key features. Include titles and scales. So we've already figured out that one point that is on this thing is 0, 0, right? So whatever our graph has to go through that point. Now, graphing the entire function. How am I going to do that? There's a couple of ways to do this. I'm not sure how she wants you to do it. Let's see, let y represent the height, let t represent seconds. In other words, one way to do this is just to plug in some values for t. Let's plug in 1, figure out what y is. Plug in 2, figure out what y is, so forth and so on. Is that the way you think she wants you to do it? Because there are some others.
I think so.
Okay, well, let's start with that, and then we'll look at some other ways. So when t is equal to 1, what is y? Where is that apple now?
hold on. I feel like it's a big number for...
Well, it's not that big. Let's just plug it in. We're going to plug in 1 for t. Now we're not squaring 18. We're just squaring 1. Okay? Remember that the exponent only operates on what is directly below it, unless it's all in parentheses. And when I'm plugging in 1 for t, I'm not putting parentheses around it. It's just minus 18 times 1 squared. Okay? Well, that gives you minus 18 plus 36, which gives you 18. So that is the height at 1 second. Now, the grid she put on the left side of this page, or did you do that?
What?
Who put this grid over here? 1, 2, 3, 4, 5, 6, 7 for the y-axis?
Oh, I did that.
Okay, let's change it, because notice that at 1 second, we are way off the grid. We're outside the page, because I got to label 18. So what I'm going to do is change this to 10, 20, 30, 40, 50, 60, 70. Now, at 1 second, we're supposed to be at 18, right there. About at 2 seconds. If I plug in a 2 instead of a 1, now what do we got?
I feel like I'm doing it wrong. I feel like my numbers are too big.
Probably not. No. Do this part first. What's that?
4.
Times negative 18. What's that?
Negative 72.
Plus, that's also 72. Which means that it's back at 0. What does that mean? What does it mean?
It's a parabola?
What is it?
A parabola?
Well, it's a parabola by definition. All quadratics are parabolas. But the fact that at 2 seconds, it's back at 0, what does that mean about the apple?
It's back on the ground?
Yeah. In other words, somebody kicked it in the air, and at the end of 1 second, it was at 18 feet, but at the end of 2 seconds, it's back on the ground. So it is a parabola. And if I wanted to graph it, first of all, I know it opens down because of that negative sign or that negative sign. Okay, parabolas that have a negative sign in front of the coefficient of the squared term, they open down. If it's positive, they open up. So, interpret the key features of the function in the context of the problem. So, what are the intercepts?
0 or... Yeah, 0 and 0 and 0 and... Or and 2 and 0?
Correct. What's the vertex?
18 and 2, 18 and 1, or 1 and 18.
1, 18. Make sure you get, it looks like you maybe did a similar thing here as you did on problem 4. You switched your X and your Y. Okay?
Okay.
In other words, the horizontal one always is the one that appears right there first. In this case, that's not exactly the x-axis, that's the t-axis. In other words, this axis over here is labeled t. Okay? All right, let's have a look at more here. Find the equation of the line that passes through those points. And is this point on that line? Well, what's our first job?
Find the slope.
Yeah. Okay. So we've got is that a 4? Yeah. Slope is rise over run. Okay, that's what you should always remember, is rise over run. Nothing but that.
Okay.
Okay, and the reason is that now I can figure out what that means algebraically. The rise is the change in what? The x or the y coordinates?
The y.
Yeah. Now I'm going to write it y sub 2 minus y sub 1. That's the change in the y coordinates. Change in the x coordinates is x sub 2 minus x sub 1. And this really is the way I would always advise you doing it. It actually is correct. If I want to switch the order, I can do it, but I got to do it in the numerator and the denominator. I can't do it to just one. Okay, see the difference?
Yeah.
Same slope. Now, sometimes the arithmetic is a little easier if I do it this way. In this case, that might actually be true, because this is y1, this is y2, this is x sub 1, and this is x sub 2. It actually is not going to be easier this way. So let's get rid of that, because I really don't want to confuse you. You always can use this way here. Tell me what y sub 2 is minus y sub 1.
Plus 25.
No, you got it right here. That's correct. What it is minus 13 minus the 12, which is minus 25. Now, what's 6 minus a negative 4?
Plus 18.
6.
I mean 8. Why did I say 18? Sorry.
Well, I don't know where you're getting the 8 from either. There's the problem. Use your calculator if you have to.
Oh, it'd be 10.
Okay. So the run is 10. So the slope is 5 halves. M equals minus 5 halves. You see how I got minus 5 halves from minus 25 tenths?
Yeah.
Okay. Now that we have slope, let me write it up here. Slope equals minus 5 halves. And I'm going to erase everything else so we can finish the problem. Have they taught you strictly slope-intercept, y equal mx plus b, or have they also taught you point slope?
I think just y equals mx plus b.
Then that's what we'll deal with. So here's the equation of the line that they're looking for. Okay? Now what I have to do is solve for m, which I've done, and then I got to solve for b. And then I'll have the equation. So y equals minus 5 halves x plus b. Okay? Now, what I know to be true is that the line goes through either of those 2 points, right?
Right.
Well, I'm going to use the smaller one just because the math is easier. And I'm going to substitute that x and y value into this equation. And what that's going to let me do is solve for b. Okay? So the y value is going to be 12. If I lose you here, stop me. The x value is going to be what?
-4.
Notice that that's going to solve for b. Now, this becomes positive 10. That whole thing becomes positive 10. And now I have 12 equals 10 plus b. Move the 10 over. I got 2 equals b. Now I have enough to write my equation. My equation always has the y and the x in it. But now, instead of m, it's going to actually put the correct slope in and the correct b. So there is the equation of that line. Okay? Now, let's answer the second part, which is that point on that line? Well, how do I find out?
You put the 16 in for y and the -8 for x.
Well, that's 20. So is 16 equal to 20 plus 2?
No.
No. So you were correct, even though you had the equation of the line wrong. That's unusual in math. Just because usually if you get one thing wrong, you're getting the whole thing wrong. Okay, let's have a look at number 3. Okay. So if t equals the cost of one taco, and that's 2, so 2 times t is the cost of all the tacos. 3 enchiladas equals 10. Okay, that's good. Correct equation number 1. And equation number 2 says must be some writing off the screen here that says it costs $6.25 if you buy 3 tacos and 1.
Oh, yeah, it does.
Is that what it says? Okay. So
Yeah.
that's equation number 2. In other words, 3 tacos and 1 enchilada costs $6.25. Okay. Now find the cost. Oops, sorry. Which one was that? This one here, I think. Yeah. So to find the cost of an enchilada and a taco, again, we have a system of two equations. There's one equation, there's the other equation. How are we going to solve this system of equations?
Elimination.
Yeah, and the reason is that in this case, we do not have one variable fully solved. In fact, it's in very standard format, where both variables are on the left side, a number is on the right side. That's standard format. So when you solve standard format by elimination, you put the two equations under one another. And it doesn't matter whether it's 1 and 2 or 2 and 1. Okay? It really doesn't at all. So what variable am I going to eliminate? This is what I'm working with over here. What's the easiest one to eliminate?
The enchiladas.
Yeah. How do I eliminate that? What can I multiply the top equation, this one, number 1? Can I multiply, even though I've reversed
-3.
By -3, exactly. Okay, so down here, I'm going to rewrite equation 1 as minus 9t minus 3e equals negative 18.75. That's my new equation 1. Sorry, I didn't mean to confuse you by swapping these two, but it's useful to know that you can always do that. It doesn't hurt anything. Now, how do I eliminate a variable? Now these are my two equations. Here, let's get rid of that line that runs in between them there. I don't need that line right there. What am I going to do to eliminate the variable e?
Just cancel out.
Add. The key is you're adding the two equations. You can't just say they cancel out, because you got to do something with the t's, and you got to do something with the number 10 and minus 1875 also. And what you're going to do is add the two equations, and when you do that, the e's cancel out. So what I'm left with is minus 7t on the left and minus 875 on the right. And now I can solve for t. T is that divided by minus 7. Let's go ahead and do that in your calculator.
No, 8.75.
No? Oh yeah, 8.75 divided by 7, basically. Since the two negative signs cancel.
1.25.
1.25, good. So, now how do we solve for e?
You put 1.25 in for t.
Which equation? Of the two that I'm looking at.
First one?
Well, you can do it in either one. Which is going to be the easiest one to solve for e?
The second one.
Probably the second one, because it's only got one e over there. This one has 3 e's. At some point, we would have to divide both sides by 3. Okay? But if I go into that equation and substitute 1.25, I get 3.75 is what this becomes, plus E equals 6.25. Now you just got to subtract that 3.75, so E becomes $2.50. And there you have it. Tacos are $1.25, enchiladas are $2.50. And that really is the only way to figure it out. And yeah, you got it all right. I didn't bother to really look at your work before going through it all. Had I done so, I probably wouldn't have gone through it because you did everything correctly.
Okay.
Okay. All right. Let's look at, we don't have much time. I don't have much wiggle room here either, but we can go look at 5. Now, the question is, where's that going to be? It's going to be down here. All right. Eek, E-E-K, who wrote that? Your teacher?
Yep.
Okay. Since it doesn't look like you know how to do either the diamond or the California method, or are both of these methods the same? I'm not even sure which. This is probably the diamond method over here on the right. I want to teach you how to do it my way. And you can do this one my way. It's not that hard. It's not an elementary quadratic. It's a little harder because of this 3 right there. In other words, what we talked about the other day was elementary quadratics, meaning the x squared term always has a 1 in front of it. Those are really easy. But these aren't that tough. Okay, I'm going to write it down here just so I have a little room to write. I want you to use the same 3 steps that we did last time we met. First step, break up the x squareds, which means breaking that whole thing up. How can you split that up so that they multiply together to give you 3x squared? What 2 things multiply together to give you 3x squared, and you have to break up the x's? In other words, it's not 3x squared times 1. It's 3x times x. That's what I mean by breaking up the x. 3x times x is 3x squared. Remember what we're doing. We're foiling in reverse. So after we're done, if we FOIL these 2 terms back together again, we're going to get what we started with. Now, what was the second step? This is where most people go wrong, is the second step. The second step is determining both signs. That is the second step. Not with this method here, not with that method there, but with my method. Both signs.
Okay.
What do both signs have to be in order to produce that -2?
Negative?
If they were both negative, that would not be a -2, it'd be a plus. Because the last step of FOIL,
So one has to be positive.
So one has to be positive, one has to be negative. And normally I would be able to write it like that and be done with it. But because this coefficient is a 3 and this coefficient is a 1, then I also have to allow it could be minus plus also and they're not going to necessarily be the same. They're definitely not going to be the same. Okay? So that's what we have to work with. Now, the last part is pretty easy. Factors of 2. Well, there's not very many of those. There's 2 and 1. So now it's just a question of trial and error. And let's start with, I'm going to start here. 1 there, 2 there. It's not normally where I would start, but I want to show you something. Is that the right answer? Now, here's what we know. We know this term is correct, right? That was easy, splitting up the 3x squared. And we know this term is correct. So the only term I really have to determine to check is this one right here. Does the middle term equal minus 5x? Well, the middle term comes from the O and the I of FOIL, which is the outside and the inside, multiplied together and then added together. Well, the inside is minus 1x, right? The outside is plus 6x. Add those together, I get plus 5x. Well, that's not the right middle term, but it's the right number, which means is all I have to do is move this 1 up to the other sign, this one right there, get rid of that one, move the 2 up to that, get rid of that one, and now the inside's going to be plus 1x, the outside's going to be minus 6x, add them together, you will get minus 5x, and we're done. We've got it. The answer is 3x plus 1 times x minus 2. And it wasn't that hard. And it definitely was not harder than these methods. Those also have a certain amount of trial and error involved with them. And mine, the only time you need to use trial and error is when you have one of these harder quadratics. But if you have an elementary quadratic with a 1 here, then there's no trial and error with my method. My method is far easier than either of these methods. And yet, even with the harder quadratic, you can still do it with my method. My method is very, very simple. Split the x's up, determine both signs, and then you want factors. Now, when it's not an elementary one, you can't say factors of 2 that subtract to the number 5. You can't do that same step unless this is coefficients of 1 only. So when you have a little more advanced quadratic like this, you just have to say factors of 2. And then you just try all of them in each position. But the nice thing is that when you try one of them and you get the right number, wrong sign, now you know the answer. Just put it with the other sign. Don't switch places. In other words, we could also have a 2 here and a 1 there. So there's 2 other possibilities, but we don't need to examine them. Because the moment we got a 5x in the middle, we knew we had the numbers in the right spot.
Okay.
Okay, I apologize. I've taken you over a little bit here, Brett. I'm going to let you go, and I will talk to you next time.
Okay, thank you.
You're welcome. Bye-bye.